Welcome back to our latest devlog for Skybound. Today we are discussing basic enemy AI and hitboxes, both aspects central to any combat system. Enemy AI refers to the programming behind non-player characters, or NPCs, that act as obstacles to the player. It dictates how enemies move, attack, defend, interact with the environment, and respond to player interactions. They shape gameplay by demanding strategic thinking, enhancing immersion through dynamic behavior, and contributing to replay value through varied responses. Well-tuned AI also maintains balance by offering a fair challenge. Hitboxes, on the other hand, are invisible shapes used in video games to detect interactions, and is how interactions between objects, characters, environment, or even the aforementioned enemy AI take place. Hitboxes uphold the integrity of combat mechanics as they define the exact periods where a character or object can be struck, or when they deliver a strike. Clear hitbox behavior helps players learn patterns, dodge effectively, and plan their moves with precision. If these hitboxes are not accurate or misaligned, players can quickly turn to frustration as they fail not because of their skill, but because the game is flawed and thus unfair. So, let's start with enemy AI. My goal for a basic enemy is for them to chase the player or the dragon when they go in their line of sight. Here, I imported a placeholder zombie to serve as our basic enemy, sourced from the link in the description. The enemy will use the pawn sensing component to see the player or the dragon given the properties provided to it. When it detects the target, it will call the AI Move To node, which will use the Unreal's inbuilt navigation mesh pathfinding system. But for AI Move To work, a nav mesh bounds volume must be placed onto the map that defines the traversable area for AI-controlled characters to move in. By pressing the P key, I can visualize the navigation mesh. The green area shows the space where the AI can move on. And voila, it works! Sort of. The enemy is chasing the player, but there are no animations. When I saw this happen in testing, I have to admit it was pretty scary seeing the enemy rapidly slide towards me. It took me a long while to figure out what the problem was, but I later found out that I needed to check used fixed braking distance for paths and set fixed path braking distance, which resolved the issue pretty quickly and cleanly. Now on to hit detection. Hitboxes serve as the colliders, the foundations of every combat system responsible for detecting combat interactions, such as the enemy receiving a fat punch to the face. A common approach for hitboxes from the tutorials I have seen was to affix the collider components to weapons or limbs, such as to a sword or fist. While this approach is perfectly valid, it is very limiting as it forces the character to use one type of attack unless I map several colliders. For example, if the collider is mapped to the sword, enemies can only be hit by the sword. What I am looking for is a flexible hitbox system that only appears when needed and allows me to freely adjust its shape, size, and position. This is where spear tracing comes in. Spear tracing is a function that detects overlaps within a capsule or sphere-shaped area. Programmers can define the start and end locations as well as the capsule's radius, offering precise control for various scenarios. When I do not need the spear trace anymore, I can simply stop calling the function every tick. To map the traces to an animation, I use animation montages. Animation montages allow users to sequence animations. They also allow developers to precisely control sections of animation sequences, add logic for branching and blending, and integrate events like sound or particle effects at a particular point in the animation. One thing I can add to an animation montage are animation notify states, which triggers logic over a duration within a segment of the animation, rather than a single event. This is preferable if I wanted to add a sword slash effect that only applies at a particular point in the animation. This makes animation notify states well suited for hitboxes. So I created my own animation notify state for that very purpose, only detecting collisions within the duration of a state I named hit collider. Each hit collider has an array. Each element in the array represents a sphere trace, which the user can directly set its properties. You can have only one trace, or you can have 100 if you so choose. Along with radius, start and end positions, I added other properties including damage, collider shape, which can be sphere or capsule, start and end sockets, and priority. Start and end sockets are used to map the start and ends of a sphere trace capsule to a socket or bone of a skeleton. This allows the hitbox to follow an animation. For example, I can set the hitbox to follow the hand for a punch or to the foot for a kick. Priority is used to resolve conflicts when a target detects multiple hitboxes simultaneously. Only one hitbox impact should be registered at any given time, and the hitbox with the highest priority is selected. When a sphere trace detects a collision, a notify is sent to an actor component called hit receiver, which records all collisions occurring within that frame and prioritizes them. In addition, it records all actors that the state has previously collided with, so that the damage will not be applied to the character on multiple frames. In the subsequent frame, the highest priority hitbox is passed to an event called onHit, which programmers can bind to. Whenever a character is struck by a hitbox, the onHit event is triggered, invoking the bound function and executing the desired response. At this point of development, player and enemy health had not been implemented, so I vowed for the next best thing. Now, there are some limitations of the system that can be improved in the future. Namely, once the hitboxes are set in the animation montage, they cannot be adjusted in real time. This means that if the character attacks with different weapons, such as a knife to a longsword, the attack looks visually bigger, but the hitboxes remain the same size, which can feel unfair and frustrating to the player. Because everything is sphere traces, there is no impact normals or force. We only know the position of the hit on the enemy. This is very minor, with little to no impact gameplay-wise that I currently know of. Though it is nice to have, and could be useful for visual and immersion, such as having blood spray at a certain direction when hitting an enemy. And there we have it, a basic foundation for a good combat system for Skybound. With enemy AI now capable of tracking players, and the hit detection system built to scale and flex with animations, The core pieces are in place to make combat feel snappy, reactive, and above all, fun. If you enjoyed this breakdown or have any thoughts on how to make things even better, feel free to drop a comment. I will keep experimenting and sharing what I learn, so be sure to follow if you want to stay updated. Thanks again for tuning in.